I am Prateek Chatterjee from the Department of Earth Sciences of JIS University. Today I am going to explain how magma is formed by melting mantle. So let's consider a simple cross section of the earth. Most people understand that the earth consists of three great compositional layers: the crust, the mantle and the core. The crust and mantle are not molten. Now the question arises that where do the magmas come from? To answer this question, we need to think about the outermost 200 km of the earth. This is the only part of the earth where the mantle can melt. We can consider the outermost 200 km of the earth as upper lithospheric mantle and crust and the underlying asthenospheric mantle. So what is lithosphere and asthenosphere? The lithosphere is cooler and stronger part of the earth because it is more rigid, it cannot convect and only cools by conduction. The asthenosphere is hotter and weaker and is able to convect. Asthenospheric convection brings the great heat of the earth's interior to the base of the lithosphere. With a depth scale, we can see that the lithosphere generally extends to 100 km of the depth. A pressure scale here we can see in the right side, and in the top side we can see there is a temperature scale. This green colored line is called the geotherm. Due to conductive way of transferring heat, the lithosphere having this type of geotherm, and due to convection type of transferring heat, the asthenosphere having this type of geotherm. Asthenospheric geotherm is called adiabatic. So the mantle is composed chiefly of peridotite, and the partial melting of peridotite produces basaltic magma. To generate magma, the geotherm must cross the solidus line, which here indicated by yellow line. We can see here. And so the geotherm must cross the solidus line of the peridotite to produce the basaltic magma. And we know that basaltic magma does exist and does form. So some special condition must exist that allows the geotherm to cross the solidus, to cross partial melting of the mantle. There are three great tectonic settings that enable the special conditions required for the mantle to melt. These are interplate mantle plume settings by adding heat on mantle, decompression melting in divergent margins, and flux melting in convergent margin. So the first way of the melt mantle is add heat from the mantle plume. So what is mantle plume? A mantle plume is an upwelling of hot rock within the earth's mantle. This increases the mantle potential temperature. Let's see here. When the mantle plume, this red colored, comes up and extends up to the boundary of lithospheric mantle and asthenospheric mantle, and there the geotherm here crosses the solidus line, that peridotite solidus line, and in that part the melting occurs. So by this process the mantle can melt and we can produce the basaltic magma. So now the second way to melt the mantle is decompression melting at mid-oceanic ridge. So what is mid-oceanic ridge? Mid-oceanic ridge is nothing that two oceanic plates are separating from each other and creating a void space, and that void space the underlying magma comes up and creating new oceanic crust. So now here we can see that when the two plates are separating from each other, then the void space is coming. So at that time the thickness of the crust is decreasing, and for that reason that here in the yellow color the geotherm is crossing the peridotite solidus line, and that part melting at that portion. So this is the another process that basaltic magma can form. The third way to melt the mantle is the flux melting in subduction zone. So what is the subduction zone? When the oceanic crust is lying under the continental crust, then we can call that settings the subduction zone. It is formed because the oceanic crust having much more density than the continental crust, and so for that reason the oceanic crust is subducting beneath the continental crust. Now let's see what happens for this reason. For that reason, from the oceanic crust the water is released, and in the asthenospheric mantle having the dry peridotite becomes the wet peridotite, and that wet peridotite having a very less temperature solidus line than the dry peridotite. And here we can see by that blue line, this blue line is the wet peridotite solidus line, and by that here the melting occurs, and for that reason here from the if we compare from the other settings, here the magma proportion of melting is much more higher than the others. So this is the another process that the basaltic magma can form. These three ways are the mainly processes how the magma forms. This all are the references, and thank you for listening me.